Good morning, everyone, and we have a very beautiful scene outside. Vancouver is beautiful. So far looks like not very exciting keynote and different developments. So a bit quick introduction about myself. I like challenges, but not the skydiving type, not the roller coaster type, but I do like challenge when it is new ecosystem emerging and most of the data coming that you can't develop a relevant workload or benchmark which can quantitatively measure the next releases or the complete platform. So those challenges excites me. And earlier I have worked in the Java ecosystem, the .NET, and now for last 2 years from Node Interactive 2015, I have been part of the Node.js ecosystem, and I love to develop the benchmark and architect them so we can quantitatively decide about the different node releases, Intel platform from the hardware perspective, as well as you can use it for your own ecosystem. So that is my part which excites me. And today in this presentation we would like to share the 2 use cases we have been working which could be part of ecosystem. And we would see what is the impact of those use cases on the Node.js ecosystem, the core, the modules, as well as how it is impacting us because we are also internally using them, and we have been participating with the different node foundation like node benchmarking and other areas, and how it is making impact in those areas. And the most important part, how we can further collaborate, because these things don't stop. Node.js ecosystem is evolving. So we want to continue to improve our workloads, our complete stack also. So they talked about 2 use cases. One which has already evolved. We have been working on it for last 1 year with community. And another just coming up. So the first one is Node-DC-EIS on the left. It's a typical Node.js enterprise use case. It is trying to exercise the core components as well as the node modules. We'll talk about in detail. We will also share how we have architected. We'll also share some data about it. It's a 3-tier model, and that means it's a little bit complex to deploy, etc. But we are trying to make it as easy. But at the same time, you want it to be close to production. There is no alternative but things a bit too complex because there is nothing easy in the production. The second case is Node-DC-SSR, which is server-side rendering. And that case is quite different than the first one, which is the more fine-grained transaction. And in Node.js ecosystem, you hear people saying, oh, don't do the compute inside the event loop, etc. That case is, we will talk about why we think it's important, and it is one of the compute intensive. It is going to take Node.js into the adjacent areas. That is where we have to address those issues. In the enterprise, Node is being used for all adjacent areas also as it is evolving. So we want to address all the important use cases, and that is the next candidate. But that doesn't mean these are the only 2 we will work. If you have a very important use case, we would glad to collaborate, and we would have later the portal and the mechanism we can work together. So let's talk about the Node-DC-EIS, Employee Information Service, and in short, I may be saying like EIS many times. We announced at the Node Interactive 2016, the version 0.9. It is a 3-tier workload with client written in Python. We could have used existing client, but they do not give the data we want at the granularity where you want to see the response time every second or detail. So that is why we worked with a simple client, and which we can keep modifying. It uses the Node.js server, and then there's a MongoDB which is storing the employee information service at the backend. It has been configured to run, as you see, the deployment could come in a monolithic way where you are using the load balancer. It may come itself in a cluster where you don't want to use that many load balancer and you want to scale within the node itself, the load balancing part. And it could be the new use case, which is microservices, where you are doing the way you have the database is deployed different way, and so you want to design in microservice way. For last 1 year, we have been working with the Node community and customer feedback on this from the version 0.9. So we would like to share that progress when we talk about the Node-DC-EIS. A bit detail about its architecture, what it does. On the client side, it does the concurrent user in Python using the green threads. So for Node.js, the concurrent users are very important. So it gives the flexibility for you to test this workload for different concurrency. It also controls the execution phases, where you have startup, ramp up, then measurement phase, and the ramp down. At the end, it produces the report with the metrics as well as the different parameter of the system resource you utilize and you want to watch. Now let's talk about the most important piece, which is the Node.js server. As we talked about, we wanted it to be using the enterprise core pieces, which are, in this case, Node core pieces, HTTP parser, the cluster mode when you are accessing cluster, as well as the main piece, which is the event loop. And because it is fine grained with the requesting a lot of network requests, it really exercising the event loop. And let's see in the profile later. All the modules in the gray, they are the Node modules. They are not part of the core, but they are very important Node modules, like Express, body parser. LRU cache is there just to benefit what kind of caching you can benefit. By default, it is disabled, but you can easily configure it to just with a property to enable it. Mongos is the one which is talking to Mongo driver, MongoDB, and Pug is for the rendering, and request and async mode are the one when you are doing the request in parallel and combine them to give one response back to the client. So these are the pieces this use case going to exercise. That was the designed architecture, and later we will see if it is successful. Now a bit, as this workload is 3-tier, because so in that case you have the 3 components, client, server, and the DB. You could deploy them on different machines. You could be in the different cloud type situation where you could put different OS instances. You could use them in the different VMs. So we wanted to define some to help you. One was single system. So that is ease of use, of course. And another one is more close to production, like 3 systems. You deploy each one on a separate system. The importance between 1 system and 3 system is, for a single system, you may not be able to see the network bandwidth problem. But in a real production environment, it is important, whether it is microservice or a thing, that you have sufficient network bandwidth between these systems to talk. And that is what will be exposed only by the 3 system deployment case. Now you have both the mode here, single instance and multiple instance. For single instance, that let you see the optimization opportunities when the system is only because Node is single threaded. When one core is fully being used, what are the optimization opportunities? That is what let you see in the single instance. But multiple instance let you see when you are utilizing the full system, what other bottlenecks happen. For example, you could have a single instance and network is not a problem. But when you are running all so many instances on it, you will see network bandwidth or some other resource problems will be exposed. And in this case, we did not want to go you find another load balancer. So we have done built in, we have a master client, and the way we separate the MongoDB out at the end, we did not want the MongoDB to be the bottleneck at the end. So we separate out. So it's almost infinitely, you can run as many instances you want, because each client is independent of others. Server is independent and the MongoDB. So you can launch hundreds. So we have tested it up to close to 200 instances on a single system. Now a bit how a typical run goes. By default, we have set 100 seconds. We just wanted to end the run quickly because we analyze. By the time you are 100 seconds, the data is very repeatable. It represents, you are able to see most of the behaviors. But sometime you may want to use it for just testing how long my Node.js server is not crashing, because many times when you let it run longer. So we designed the workload in such a way that if you let it run for days, then it should not overflow on certain files, logging file and other files. We have tested it for running at least for over the weekend for 2-3 days for now, but we would glad to work with, let it run for a week or more. But we designed it such a way that where the data you are collecting is analyzed every few seconds and it's not piling up. So we thought of that architecture from the beginning just for that purpose. Once the run complete, you will see the throughput and P99 response time. You do have in the report the detailed response time, like min, max, mean, but most customers are sensitive to the 99 percentile. They don't want even 1 or 2 customers getting irritated because of the latency services. So that is why for the this workload, we wanted to make sure we are representing the customer needs. In addition, when we were testing, we were finding, particularly for multi-instance, we were finding sometime the CPU utilization drops, sometime it will not scale. So we were running the workload, and we were collecting these CPU utilization, other tools, data, and we were trying to match. It was not very efficient. So we thought, why not built into the workload? So right now from the client side, it makes call every 1 second, what is the memory use in the node, what is the CPU utilization, what is the network utilization, and that data is there in the report once it is generated at the end to see for you to easily correlate. If there was a dip, where was it? Did my CPU and network also drop same time? Was the dip due to because my memory went oversubscribed? So we're trying to correlate those things. So please share like what are your pain point, what other things you would like to add so that it help you for your environment. Now I wanted to give a bit summary, like what happened from the last Node Interactive version 0.9 to today we are 1.2, and what different changes happened. So we worked with one of the very important feedback. We want to thank Microsoft Azure Chakra team. They have given extensive feedback based on their use case. So they are using, they wanted to see for make it easy containerize. So they request for the containerize. We did the containerized version and we all tested it pretty heavily, and it worked very well. The another point I was talking about the network bandwidth issue, we noticed that the latest Intel processors, we were trying to run on them and we could not saturate the system. And what we were finding later that the network bandwidth was hitting the point, the maximum capacity there, the switch, the Ethernet capability we have there. So we make the dynamic set size where you can small, medium, large. So default we picked where right now it is actually 5 gigabit when you load the system fully. But if you want to test, let's say tomorrow you have a 40 gigabit switch or some, you can configure the data set size to really exercise that to max. Or if you really got the system, you haven't set up the network part yet fully, you only have 1 gigabit, you can reduce to a small size and you can still set the network part stressing. Another improvement came from the MongoDB layout. With Nearform Matteo we were working. He suggested the way we design the MongoDB with different schemas, he said that is how it is not being done in the production environment. So we worked with them and made it to that is how more represented with the MongoDB case. That was just to make overall call and the mechanism relevant to the enterprise client. Since we used it extensively, we also improved client. For example, we were talking the system monitoring data we have to correlate later, or in the report formatting, some of the things were not obvious. We have to really look in different places. So we try to make it more intuitive onto the several areas. So these are the changes. These changes look minor. Most of the core was developed by 0.9, but these changes really make the life easier. They really improve the usability of the workload. Now a great milestone for us too. Intel have been working with the node benchmarking group. So how many of you are aware of the node benchmarking or you heard of the node benchmarking? very few. So that is the interesting part of the Node ecosystem. We are finding that it has, when you are testing the Node LTS, another part, it has the core benchmarks, but they are mostly testing for functionality. They are not testing for the performance impact. You could have some dramatic performance drop and it will not be caught. So for that part, we are working with the Node benchmarking group. Thank you, Mike Dawson, for helping us in this part. And now the Node-DC-EIS is part of the Node benchmarking group, and it is running, doing the daily builds. You can see the impact on it. Node LTS 4, if you take as a base 1.0, the 6.0 is 15% better, is showing that improvement. The LTS 8 is 65% improved. So you can see how the significant improvement from V8, from Node, other APIs has gone into it. The master is only 50% over the base, so you can see master is slightly less than the LTS 8, which is expected because so many patches are still continuously going. But it helps to see, it is showing, the workload is already showing the impact. And one of the parts, you can use it for your environment. Let's say you did a change in your Node application. Now you're not sure the impact came from the Node, impact came from some hardware configuration. So at least you have a benchmark or workload number, and you can take this, run it there. At least you can make sure that the Node release is fine, the hardware configurations are fine, and it is something to do in your application with this bottleneck, the change. So it helps you to make sure rest of your platform is responding well. So that is where how a known workload, a known number, expected number, helps you to at least debugging in your environment. So please use it that way and give us the feedback. Now one more addition to that part. Remember the Node benchmarking running certain Node benchmarks on the hardware. We have actually contributed the not the latest, one older version of the hardware to the Node benchmarking also, and it is being used for some release testing, but not latest for the Node benchmarking. So we have the additional performance testing, which is called Language Performance Lab. It is running all runtime. It is running Java, it is running Go, it is running PHP, Python, including Node. So the difference from the Node benchmarking would be, here we control the hardware. So we try to run on the latest hardware your Node releases. And in addition to, the Node benchmarking may be running the particular build of the V8. And as you saw from the keynote, like on the LTS 8, early version of the V8, Google was announcing like how they found certain performance aggression. On the performance lab, we could run the Node LTS or the new master with the latest V8, which will not be in the Node benchmarking. So they can be complementary, where the Node benchmarking running with a given V8 and language performance could run with the latest V8, so we can see in advance and fix the issue early. Otherwise, the Node.js build gets stopped because it's not working well with the latest V8. So please look at those numbers too for your environments, and we would be glad to take the feedback, improve the language performance portal. And for example, here it is using a 6.x, the base comparing with the master. And it's a continuous, again, number showing to show the regression to identify opportunities. Now let's talk about how the Node-DC-EIS profile looking. So far we designed it, we tested, worked with different customers, feedback from others. Let's see how it is looking. So on the left side is the flame graph. That one is just to see the full system wide, how it is looking. So this is for 100 seconds, and as you can see in the beginning, the Python client is also there because that is also a significant piece. NPM loading is happening, and then we have the Node V8 part as well as the JIT code. So profile is matching the expected behavior from the Node core as well as the Node modules we were expecting. Then we wanted to have another tool too, not just trust one flame graph. So we have the CPU clock tick profile also, and 30% is JavaScript, 60% into the C++, and around single digit 5 to 6% in the 3 other component of GC, shared libraries, and unaccounted is JIT part also goes there. So it is showing that we are going into the shared library, the libUB, V8 and other code. So it's matching the flame growth profile, expected design, as well as the CPU clock ticks part. So we are pretty happy with how the profile looking. After checking the profile it is behaving, we wanted to see how it is responding on the full system. So we ran it on the older generation of Intel Xeon processor, which are E5, and the latest one are the Intel Xeon processor scalable family. Tongue twister, but yes, that is how it is. And it is delivering almost 49% performance gain. So how it helps, you are in the enterprise and you buy the latest hardware and your application not scaling, you can take a workload and check that rest of the configurations are fine. Because many times the networking, the memory, there could be sometimes some configuration which are not optimal. So a given benchmark once again helps you, and a published numbers a bit helps you to showcase what improvement you should have got. And then you can look at your production environment and app, why mine is not getting similar boost. Of course, the profile could be different type, but if it is matching the profile we were trying to do, atypical. And in addition to it, you could also modify the workload. The way it is given, for example, the MongoDB side, the employee DB records, they have 10,000 records. You can make them more number of records. When you want to do each search, by default we have a last name going to match 25 names. So that much data will come. You can make it 5. You can make it 100. With 5, you have very fine grain. Response going to come fast and less amount of network. With 100, MongoDB going to take long. So now if you have high concurrency, your event loop will pile up with lot of requests. And the MongoDB will take longer to respond because it need to collect the last name matching for 100 and send you. So you can configure it for different things. And also the request mix is different. So you can use this workload, design it to your environment, and test it for hardware evaluation, for your own evaluation of different LTS, or other testing of your application if it matches similar. Now a bit the concurrent users. So this part is also pretty important for the node because that is one of the strengths of the node, that it can handle the high concurrency modules. For that part, we have tested 10 concurrency, 100, and 1,000. If we have gone up to like 10,000, and in that case, we start seeing the failures on the part. So if you look at, it is a single thread, which is single monolithic. For 10 itself, 10 user itself are saturating the system. So that is what is being reflected, that on the throughput side, you have 10 users or 100 users or 1,000 users, throughput is not increasing because even 10 users were able to fully utilize that core. Now, what happens on the latency? That is where you have the interesting part, that after from 10 to 100 to 1,000, latency jump from 10 millisecond to 900 millisecond because you're waiting more in the queue, you're waiting more in the event loop, etc. So the workload is reflecting that is how it should have behaved for the concurrency testing. Now we wanted to summarize a bit that what is the current status of 1.2. It's already been on the GitHub where we uploaded it. So we already make a lot of changes. We are extensive testing, and it's already part of the node build for the node benchmarking. It's part of the language performance portal lab. So, and we will continue to test on the latest hardware and different platforms. We would love for you to try it on the GitHub part and suggest us as how we can make it more useful. 1.2 is not stopping. We are not stopping at it. We want to continue to evolve, and we want to continue to add the usability. For example, there are some new modules coming in the node, like there is a worker module, which let you do multi-threading in the node. We are very interested on that part. There could be HTTP 2.0. There could be VM neutrality, other node cases. It is pretty easy now. We have a well-established candidate for the workload to either add to it or as it is be able to test those new modules coming up. So you can leverage them with confidence, with some quantitative measurement, how they are behaving. So please evaluate, and we would glad to work with you. Now the second case, which is just evolving, just starting, alpha version, I wanted to talk that one. So this one is server-side rendering, which is pretty important for enterprise, and one of the reason is search engine optimizations helps it, as well as the latencies when you are sensitive to latency. So there is a more and more enterprise like Walmart, PayPal, or Netflix, they are using the server-side rendering. So let me just quick, how many people are heard of the server-side rendering? Quite a bit. How many are using it? 5 or 6. So this is a different use case. As we were talking, it's a compute-intensive use case. And Node have been very successful, fine-grain, I/O distribution, get the work done from somewhere else. This case forces you to get the work done inside the event loop. And when the event loop is doing that server-side rendering for up to 100 milliseconds, it is not responding to the other requests which could come. So, and people are using it. It's an important use case because it helps. The part is for server-side rendering, Node is not the only ecosystem. You can do with Go, you can do with Python, you can do with Golang, etc. So we want to see the Node.js growing, addressing the adjacent area. We want it to be better than others. And that is our opportunity when we have a use case in a quantitative manner that you can evaluate and see how we can improve, which library can be improved, which native call or what do we need to do add on. For example, worker thread module might be really great thing for these kind of case. So the one use case we are so far using, we in discussion with Walmart Labs, they have you could have a client, and one of the reasons they like, you could have a very thin client, a strong client, and they wanted a response time which is consistent across all devices. That is one of their goal. So the request comes, and they have even open sourced the Electrode framework. It rendered through the Electrode framework, and you get the response back. It is a very extensive compute data being collected from a lot of places. So that is a very interesting use case. We work in collaboration with Walmart. So today we would like to share with you the Node.DC-EIS version 0.8. It is very alpha. It is using the Electrode from the Walmart, which is open source. And we have put the code at the GitHub. Please go look, evaluate. You can test and run. A little bit detail how we architected. To keep it consistent, we are using the same client, what is part of the Node.DC-EIS. So you are familiar with it, and you are getting the same similar consistent data for throughput, 99 percentile, report output, pretty matching. What it exercising on the server side, that is totally different. On the server side, it is modeling a commerce page. From the, in this case, we looked at the Walmart because that is what the Electrode we were using, but it doesn't need to be restricted to Walmart. So we made it configurable. Right now, it does dynamically 10,000 HTML tags, but we made it configurable. You can, if your page for your enterprise is a couple of thousand only HTML tag, you can set it. If it is much higher, you can set it. And it is by design around 15 deep, the nested of the HTML tags. It is using the Electrode component, which is React, and it is using the Redux, Harpy, and the Material UI. One of the things, there was a recent announcement, for example, Electrode for now is using the React 15, and server-side rendering change with the React 16. So it will be very interesting when we change how it is reacting to the different pieces. So to summarize, we shared today the two use cases, Node-DC-EIS, which is 1.2. We tested heavily, already part of the node benchmarking and language performance lab, as well as other testing for the full servers, latest servers all. The second case is the Node-DC SSR, which is 0.8 alpha. We would like to collaborate. And Walmart case is not the only one for the server-side rendering. Please share your case, and we would glad to add another use case for the server-side rendering. And when it is 1.0, we are planning to hopefully in next quarter, we would love to add it to the node benchmarking, to the performance lab website I was talking about. And we will continue to test, even evolving from 0.8 to 0.9 to 1.0, working with you guys on our latest platforms, the all Intel scalable servers, to make sure when your enterprise get them, you have something to quantitatively check if things are scaling or what different resources it is stressing. And we have our here very strong team from Intel, even at the Node Interactive here. We would love to continue to participate, understand the different use cases, and to understand and improve. And we have, for the collaboration part, because otherwise we are distributed, we have opened the GitHub, that Node.DC, which is Node.js for data centers. So please give your feedback there, open issues, download those cases. And here we have our team. If you want to any face-to-face, Uttam Kumar, if you want to stand up, please. You see him, he's the core architect for the Node-DC-EIS and server-side rendering. Please pick him up and talk. And I'm very open to learn more use cases. And we also have our principal architect here, Suresh Srinivas. So please pick us up. We are really happy, we are really excited to be part of the Node.js ecosystem and love to contribute and work with you. If you have any questions, you can catch me outside, or I think we have probably a couple of minutes. Anyone has any questions? Okay, so please use the benchmark, because so far functional testing is great, and quantitative testing on a large scale server, and when you go large into cloud, we are hoping that is where the Node.js next adoption is coming. The exponential rise need to continue into that phase, and we want to be critical contributor into that component with your collaboration. Thank you very much.